What's up? Welcome to another video of this SVA Design YouTube channel. Yeah, back at it again, working on the single-seater car. I still haven't got a name for it, and hopefully at the end of the series I might have some suggestions from you guys. We'll see what I end up with. But in the time being, I basically was trying to do a speed art video for today. Recording how I kind of made the frame of the car, the tube frame, the section that connects the gearbox and the engine and everything to the carbon fiber monocoque of the car. And then I forgot to press the record button when I was trying to record it, and I made it all the way. And not that it's a really a difficult thing to make, but you know, I kind of figured maybe it's better to kind of do an explanation video on all the structural integrity, yeah, you know, all of those things, all of those components. Just do explanation on safety things and how it works in my mind, because as you guys know, I'm just a 19-year-old kid with a hobby, and I haven't really gotten a degree in doing any of this. So this is just all based on how I think things will work in reality. So yeah, that is coming up next. So now I'm just waiting on this rendering to finish, and then I will be back with you in a second. The first thing that you will kind of see on the front of the car is this, yeah, let's call it like a crumble zone, but it's kind of the luggage space of the car. So this is the only space where in the car where you will actually be able to put like a book bag, or maybe you could go to the store and put like a loaf of bread or some milk in there or whatever. But you know, this car, as you can see, is probably not built for practicality, and those aren't really high priorities on the list, but you should probably still be able to put some stuff in the car. So that is what this purpose serves. The next thing, structure-wise, what this does is that it's kind of it holds all the front suspension components that have to do with spring and damping, and also the anti-roll bar mechanism with the push rod and all of that. So that is what it basically does and what the purpose it serves. And also in the front head-on collision will probably, because it's like an aluminum, softer metallic type material, then it will probably be also capable of absorbing some of that impact energy, and yeah, just some rigidity and all of that. So that is basically the purpose it serves. And again, just another how you call it, another disclaimer: I'm just a 19-year-old kid, and I don't calculate nothing that you can see in here. So this is just all going off educated guesses, not even educated guesses because I'm not educated, but I'm just kind of seeing what other people doing and making them my own versions as I go. Second part is this carbon fiber monocoque structure. So it holds the seat, obviously, and it won't be like a solid carbon seat. There will be some cushions or some padding or whatever to make it more comfortable, and I will design that later on when I really dive into the interior design of the car. And I've also already finished the steering wheel, but that is not in this file yet right here. So to continue with the carbon fiber monocoque, you can see that the bottom wishbone is attached to it, and if you can look at it from like this front angle, you can also see that the top wishbone is longer in length than the bottom wishbone is, and this is something for suspension setups that is not really beneficial. So I will kind of modify the bottom section right here of the monocoque to get and also modify this suspension arm to get a longer length suspension arm, so that it will basically be from the center right here. Yeah, the suspension arm, but I don't know how much I will do it, because I'm trying to use this space right here for battery storage, so I have to be careful with how much space I actually reserve for this. So there will be something of later. I'll just worry about that later on. Attached to this carbon fiber monocoque is also this carbon fiber frame piece that will hold the steering wheel, but is also responsible of holding the upper wishbones. And as you can see, this upper wishbone right here is attached to that, and then attached to the wheel carrier, and also attached to this upper wishbone is the pull rod that will actually drag onto the spring and everything. And in other videos I've really dove into how that works and all of that, so you can just go to the channel and look at the anti-pull rod mechanism explained and all of that, and to get more information. So this wheel carrier is also being held up by these two wishbones on some rubber bush mounted ball bearings, and attached to that is this braking system, which you can see is just a carbon braking system, but I will probably look for some ceramic material or even a metallic material to make it cheaper for track days if you would want to replace one of those things.
And the brake system itself is a 6-piston caliper with individual caliper sizes, so they're not equal in sizes, all of them are different. And this has to do with just spreading the force of the pressure on the braking pad, making it better to also wearing and all of that, so just better braking overall performance. And I will dive into the explanation later on when I have a little bit more time to prepare also for this topic. And the wheels themselves are carbon fiber brakes, and this shape is probably way too complicated to make a carbon fiber shape of them, and so it will probably be very hard to actually fabricate it. Probably it'd be even impossible. But with the new Lamborghini possibility of forging carbon fiber in different ways, it probably will be able to produce these shapes and still have a very lightweight, rigid wheel with a very low mass and everything. And also it is a center lock, and yeah, that is about everything I can tell you about the wheel. They weigh about 6 kilos if I'm correct. And also the steering rack right here, so you can see that the steering rack will be attached to a steering wheel that is right here. And yeah, that is everything from the carbon fiber monocoque and back towards the rear of the car. So you can see that right here there is a chromoly frame, and this will weigh probably something around 30 kilograms, and it is on both sides of the car obviously. And this will be attached with some titanium bolts through the rear of the monocoque, the carbon fiber monocoque. And it on this side it will be attached to this case, and this case is like the first start of the gearbox case, but also at the same time the part that keeps the engine block together. So it will be directly bolted to that, and that will also kind of make you feel all the vibrations of the engine if you are driving on the engine. But if you just want to cruise, then we have these monstrous electric engines that will motors that will propel you down the car in complete silence if you so wish. But we'll get to those later in the specification of them and everything. So the engine itself, it's a 2-liter V6, and I've used a very high border stroke ratio. So this will be an engine that produces a lot of RPMs, and it also produces peak power at a high RPM. So if my guesstimations, as I call them, are right, it will probably run at something like 12,000 RPM. And because it's a 2-liter, with that and also attached to some Koenigsegg free valve technologies and everything, I think that a friend of mine calculated that is still in automotive engineering school, that this engine will probably be capable of producing something around 500 brake horsepower. And also with the air intake, you can see that I've mounted variable air intake length runners, and what these do is that they can adapt the intake runner length on various RPMs of the engine to create better suction and to have more air actually get into the combustion chamber at different RPMs. So that is basically what that does, and more air means more fuel to burn, means more horsepower and all of that. These 3 things that you can see right here, this one is for motor oil, so it's a dry or sump engine. This one is for a compressed air tank that will regulate the free valve mechanism, and this one right here is a 50-liter or something like 15 gallons of fuel. So that is what that is right there. And as I said, somewhere in this region will be the battery pack, and I will be using something like 125 kilograms of batteries. In here is a 6-speed gearbox, and if you can hide that, you can see that they're all straight cut gears, and I don't remember the individual gear ratios, but you know, I've also not really been very careful with the gear ratios, but it's kind of equivalent to, let's say, BAC mono gearbox in the way it's created. It's all straight cut gears instead of having these curved cut gears, and you know, synchro meshes and all of that. So the clutch, it's a single clutch. It's not a double clutch, but it's all multi-plated, very lightweight, no flywheel attached to the gearbox whatsoever. So that is also another thing that's added to the car. And then via this output shaft, there is a differential in here between the 2 electric motors, and that is where it gets interesting, because it is a open differential, but with the torque factoring of the electric motors, you can kind of simulate a limited slip differential by aiding the differential with these electric motors in producing horsepower on which wheel you need it, and also the engine power will then be directed to the place where the horsepower is needed and can be put to the ground more efficiently than in the other place. So that is basically what these electric motors will do, what their purpose will be, and at the same time I also will be using them to produce a boost system in the car. So the specification of these e-motors are that they're Yasa 750Rs, and the 750 and 750R means that they are 750 foot-pound of torque to put onto the ground directly and without a gearbox attached to them or whatever. And but I don't really feel like I need all of that at one particular time. So when you're just driving in regular situations, you will be just putting down, like, let's say 100 horsepower per wheel and also like 100 newton meters of torque to add to the engine. So that would make for the complete car to be something like 700 horsepower. But let's say you have like a 7-second extra boost as soon as you push the button on the steering wheel. So that is basically what the purpose of those serve. So they aid the differential, and also at the same time they will give like video game type of nitrous, but instead of nitrous it will be electric boost. These two cases that are on top of the gearbox right here are inverters, and what inverters do, they take maybe a high voltage or a high amount of other type of electric energy, and they convert it to a type of electricity that the e-motors would like to use. So let's say the e-motors use a high amount of voltage but a low amount of I don't know how you say it in English, but the other type of electricity, I really don't know the word right now, but then these kind of converted towards that type of energy for the e-motors to use. So that is what they do, but basically they also produce a lot of heat, and that also requires a lot of cooling. So if you can see, like the Koenigsegg Regera, they have an exhaust piece at the end of the car, and that is solely based to keep these cool. So we will need some kind of similar system that we will have some air intakes right here, and those will draft air right to these to kind of keep them cool. Or maybe we need to have air to liquid and have liquid to liquid cooling in here, and we'll have some hot air exhausting happening right above the gearbox underneath the wing that will be sitting right here. So that is everything technology wise. In the construction, all of this will be steel chromoly shape, and as you can see, a lot of things are also attached to the gearbox and the differential case if it comes to suspension parts and all of that. So those would be all made out of aluminium or aluminum, depending on where you live. And yeah, those will kind of be also a big structural piece in the car. So right here you can see that also the suspension parts and everything is mounted to that, and I still need to make the mounts on this case right here for the pull rods and everything to be assembled to. But also these wishbones, one of them is attached to the gearbox and the other one is attached to the differential case. So this wishbone will actually also keep everything together and make the assembly even more rigid and more stiff. And just all of these components are being used as structural mounts, and to also give extra rigidity, but also to save weight and not add another frame piece to the complete car and all of those things. So yeah, I think we probably basically just went over most of everything. The last thing that I do want to mention, or the second to last thing actually, is that the way I see it and the way the car would need to be engineered as soon as I send it off to someone that actually knows what they're doing, is that in event of a collision, a sideways collision, like let's say if someone impacts you right here, then I feel like this section of the car, the monocoque section and the front wheels, should just be detached from all of this right here, because this is where the engine is, the fuel cell and everything. So it kind of should break loose right here at this point, so that you also have less weight to carry around, and the kinetic energy, if you have a secondary impact, will be way lower than if you would have the whole car connected to each other with a bunch more weight. So another thing that I wanted to show you before I leave is the total mass of the car, and I think it will be something around 400 kilograms, and we just have to wait to get that to load. It has to calculate for every component individually what the density is and how much of that material is actually being used in that component, so it will take some time. And there we go. So 411 kilograms. as you can see right here. So that would translate loosely into like let's say 850-ish pounds. And you can also see that that center of mass is right here, so it's actually, the center of mass is actually below the center line of the wheels, barely, or just on it. And it's also a little bit more towards the back than towards the front, but there will be still low down in this area right here. There will be the battery cell, so that will kind of drag it a little bit more to the front and also a little bit lower down. So I think eventually it would end up being somewhere in this section, so it will be pretty much 50-50, but you know, we still have some work to do on also the body panels, and those will be added on as accordingly. And all the body panels will be just shrink wrapped around the car, and I can also show you a little bit of lines to give you a little bit of a preview of what it would look like. So that is basically the roof line, but and I've also came up with a pretty amazing and creative and just also innovative rear ring system, and also with some front diffuser and all of those elements that will come together with the aerodynamics and all of that. And yeah, I just can't wait to show you what that would look like. So I'm also very excited to kind of begin on all of that, to start with just the body panels and all of that. So yeah, I can't wait. Also, first, another the final last thing that I wanted to ask is what the name of this thing will be, because I'm stuck with this single seater name. So I will close off the video with that, just something to think about. Thanks for watching. Please leave a like, subscribe. Also make sure to like the video and leave me a comment on what you think that I could improve upon, or what you like or what you dislike and all of that. Just yeah, keep me posted. See you guys later. Shaquille Veldboom, SVA Design. I'm out.